All right, let's dive into one of the universe's most mind-blowing forces, the strong force. You wanted to learn more, and we've got some cool research to share. We're looking at this article, pasted text, focusing on two parts. One, the latest discoveries, and two, a possible link between the strong force and gravity, which, if you think about it, is pretty wild.
Yeah, it really is. I mean,
Yeah.
the strong force is what holds the very building blocks of matter together. But we're finding hints it could be connected to the force that shapes entire galaxies.
Right. It's almost like, I don't know, finding out the tiny screws holding your bookshelf together are related to the moon's gravity or something. So, before we get into these crazy discoveries, let's do a quick recap. You probably heard that the strong force is what binds the nucleus of an atom, right? But why don't we ever isolate a single quark? You know, those particles that make up protons and neutrons?
Ah, that's where things get really interesting. See, the strong force actually gets weaker at super close ranges. This is called asymptotic freedom, and it was a huge deal in physics. It explains why we can never just pull apart a single quark. They're always trapped by the very force that binds them.
So, the closer quarks get, the less they feel the strong force. It's almost like a rubber band getting tighter the further you stretch it.
Exactly. And that leads to something called color confinement. Because the strong force increases with distance, quarks are always grouped together, like in protons and neutrons. This makes sure they have a neutral color charge.
So they're like playing a cosmic game of hide and seek, always sticking together to avoid being seen alone.
That's a really good analogy. Now, about quarks and the strong force, there's some big news from particle physics. The ATLAS experiment at CERN just made a record-breaking measurement of the strong force's strength.
CERN, that's that place with the giant particle collider, right? What did they find?
Well, they use particles called Z bosons. They're kind of like heavy photons to study the strong force during collisions. And get this, they measured the strong force's strength with an uncertainty of only 0.8%. That kind of precision is unheard of.
Okay, but why is that a big deal? I mean, it just seems like a small number.
Well, imagine trying to measure the Earth's diameter to within the width of a human hair. That's the level of precision we're talking about. These really precise measurements let us test our theoretical models really accurately. And who knows, maybe even uncover new physics we don't even know about yet.
So this incredibly precise measurement from CERN, it's not just about numbers, it's leading to some really wild theories. Like, are you ready for this? The idea that the strong force, which governs the tiniest particles, might be linked to gravity. You know, the force that rules on the largest scales.
Yeah, that does seem counterintuitive, right? But researchers at the Thomas Jefferson National Accelerator Facility had been doing some interesting work. They've actually figured out how to peek inside a proton and measure the strong force's distribution.
Hold on, how do you peek inside a proton? That sounds impossible.
It's really complex, but they use something called deep inelastic scattering. Basically, they bombard protons with electrons and study how the electrons scatter off the quarks inside, like shining a superpowered flashlight into a proton and mapping out its internal structure from the shadows.
Wow, that's amazing. So, what did they learn about the strong force inside a proton?
Well, they found that the strong force is incredibly concentrated inside. It would actually take over 4 metric tons of force to break the strong force's grip in a single proton.
4 metric tons. That's like trying to rip apart a microscopic black hole.
But how does any of this connect to gravity?
If we zoom out and look at the bigger picture, understanding how gravity and the strong force interact could totally revolutionize our understanding of how the universe began and how it's changed over time. Remember, right after the Big Bang, all 4 fundamental forces were one. Then, as the universe cooled and expanded, they split apart, becoming their own forces. But maybe there's still a connection, like a hidden bridge between the cosmic and subatomic. So you're saying that even though gravity and the strong force seem so different now, they might have been the same thing in the early universe.
Exactly. And if we can figure out how they interact, it could unlock a whole new understanding of the universe. There's this really interesting idea called the double copy principle. Some physicists think it could be the key.
Okay, I'm intrigued. The double copy principle. Tell me more.
Imagine you're trying to solve a really hard gravity problem. The double copying principle is like saying, hey, maybe there's a similar problem in the world of the strong force, but way easier to solve. Solve that one, and you might crack the gravity code too.
Like finding a secret decoder ring for the universe. But how does that even work? Is there any proof to support this?
Well, it's still kind of early, but there have been some pretty amazing successes using the double copy principle. For example, some researchers used it to calculate the gravitational waves from colliding black holes, and their results matched up perfectly with Einstein's theory of general relativity.
So we're talking about a potential game changer in physics, right? If this double copy principle is true, it could rewrite our understanding of how gravity works and its relationship with all the other forces.
Exactly. It's like finding a Rosetta Stone for the universe, translating between gravity and the strong force. It might be the key to finally figuring out a unified theory of physics and developing a theory of quantum gravity, which would be huge.
Okay, that's a lot to process. We've got these super precise measurements of the strong force, hints that it might be connected to gravity, and this potential decoder ring to unify physics. But I still have so many questions, like how does the strong force actually work? What's going on at the quantum level that makes it bind quarks together so strongly?
That's where we get into the world of color charge. See, these quarks we've been talking about, they come in three colors: red, green, and blue. But these aren't like the colors you see in a rainbow. They represent a fundamental property of quarks.
So it's like a cosmic paint by numbers, where each quark has a specific color charge, and that determines how it interacts with the other quarks.
That's a great way to think about it. And just like mixing red, green, and blue light gives you white light, combining all three color charges makes a neutral colored charge. And here's the important part. Quarks always combine in ways that create a neutral color charge.
So it's like a cosmic rule. No quark left behind without a color-neutral partner.
Exactly. And this rule is enforced by particles called gluons. Gluons are like the messengers of the strong force. They're constantly moving between quarks, swapping color charges and keeping them bound together.
So gluons are like the messengers making sure everyone stays in line.
You got it. And what's really wild is that gluons themselves carry color charge, which means they can interact with each other. This self-interaction makes the strong force super complex and different from other forces.
Wait, so gluons bind quarks together, but they also interact with each other, creating this web of interactions. It's like a cosmic dance party with everyone swapping partners and changing colors.
That's a great way to visualize it. This whole dance of quarks and gluons is what makes the strong force so strong. Remember those 4 metric tons needed to break the strong force in a proton? That just shows how powerful this force is.
It's mind-blowing that all of this is happening inside every atom in our bodies, constantly and effortlessly. But this incredible force, the same one that holds the universe together at its core, could also be the key to solving some of humanity's biggest problems.
Absolutely. Think about energy. Fusion power, for example, relies on the strong force to release energy by fusing atomic nuclei. Imagine having the power of the sun here on Earth. Clean, safe, and pretty much limitless energy.
Okay, now you're getting me really excited. But fusion power always seemed like a distant dream, like something out of science fiction. Are we really close to making it a reality?
We're closer than ever before. There have been so many advancements in fusion research recently. A lot of scientists believe that practical fusion power is within reach, maybe even in our lifetime. And understanding the strong force will be essential for getting there.
So we're talking about a force that not only shapes the universe as we know it, but could also solve our energy crisis. That's incredible. But I have to ask, are there any downsides? Could there be unintended consequences to using such a powerful force?
That's a good question. Any new technology comes with potential risks, of course, but the potential benefits of fusion power are huge. It's worth pursuing it carefully and responsibly. Imagine a world without fossil fuels, where energy is plentiful and clean. That's the kind of future we could build if we unlock the secrets of the strong force.
It's exciting and a little scary to think about the possibilities, but one thing's for sure. The strong force is not just some simple, static force. It's dynamic and constantly changing, shaping the universe around us. It binds us, powers the stars, and could hold the key to our future.
And the more we learn about it, the more we realize how much more there is to discover. It's a journey into the heart of matter. And the discoveries we make along the way could change our understanding of the cosmos and our place in it.
That's beautifully put. It makes you wonder what other secrets the strong force is hiding, just waiting for us to find them. Maybe one day we'll discover it's connected to even more of the universe than we can imagine.
Yeah, it's amazing, isn't it? This tiny force holding atoms together leads to these huge discoveries about the universe.
It really shows how everything's connected, from the tiniest particles to those massive cosmic structures. It's all ruled by these forces. And the more we learn about one force, the more we understand the others. We find these hidden connections and new things to explore.
It makes you wonder what other mysteries are still out there. We're only starting to understand the strong force, And it's already opened up all these possibilities in physics, cosmology, even energy production.
Absolutely. And imagine the technology we could create if we really understood the strong force. New materials, advanced medical treatments, maybe even quantum computers. Wow, now that's really thinking big. But it makes sense, right? Every big scientific discovery leads to new technology that changes the world. Who knows what amazing inventions are waiting for us as we learn more about the strong force?
It's an exciting time to be alive, for sure. And something we've learned in this deep dive is that the strong force is anything but simple. It's dynamic, it's complex, always changing, always interacting with other forces, and we're just starting to figure it all out.
It's like we started by seeing one tiny brushstroke, and now we're discovering a whole masterpiece. Each new discovery revealed another layer of complexity and beauty that we never imagined.
Exactly. And it reminds us that our quest to understand the universe never really ends. It's full of surprises and wonder. Even something as basic as the strong force can still amaze us as we dig deeper into its secrets.
So, as we wrap up our look at the strong force, I'm left feeling awestruck and curious. It's humbling to know that we're just a small part of this vast, complex universe, ruled by forces that are both powerful and mysterious.
And that feeling of awe and wonder is what drives scientific discovery. It pushes us to ask questions, to explore, to push the boundaries of what we know.
Well said. And to our listeners, we encourage you to keep exploring too. Dive into the world of particle physics, ponder the mysteries of the cosmos, and never lose that curiosity. It's what fuels our understanding of the universe and our place in it.
And as you explore, think about this. Could we one day harness the immense power of the strong force? Could we use it to solve some of humanity's greatest challenges? The possibilities are mind-blowing, and we're only at the beginning of this journey.
On that note of optimistic curiosity, we say goodbye for now. Until next time, keep exploring, keep asking questions, and keep diving deep into the wonders of the universe.